Hello, today we're going to be talking about function notation and evaluating functions. We're going to look at different types of notation. Function notation, so remember function notation is another way of writing y equals. So y equals 2x minus 5 is function notation is f of x equals y. So what we do basically, we take an x value, we put it into some function, and out comes a y value. Alright, and this thing is called f of x. f of x. Alright, so f of x is what it's called. f of x. So the values that go into the function are your input or your independent variable. Those coming out for y are the dependent or the output or dependent variable. Now, what we're going to be looking at is this notation and how to evaluate this notation. It's the function notation is just another way to write your y value, and we're defining it in terms of a function so that we have different notation for different functions. We have different names. So it's just a different way of writing what's coming out of the function. Alright, so we're going to be looking at evaluations like f of 3. So if we have f of 3 here, we're going to be basically going to write the function as the 3 value going in for x. So we're going to actually have this value of 3 being plugged in to the value of x in the function. We think of this as the rule of f of x. So this is the value that you're going to put into that rule for x. So in this case, the answer is 6 minus 5, which is 1. So to evaluate the function, we just put it into the x value. Sometimes we ask the question is when the function itself equals a value. So when does the function itself equal a value? So like 3. If we want to know when the function equals 3, instead of when the function inputted 3, we're asking when is the output, when is the dependent variable 3. What we would do there is we would take our function, which is 2x minus 5, and set it equal to 3 and solve. So you'd add 5, and you get 8, and you divide by 2, and you get 4. So 4 is the value, your input value, that will give you 3 as your output value. So if they're asking you to evaluate the function, they're asking you to put 3 in, they're going to put it inside this parentheses with the function notation. If they're asking you to find out when that value is, what we do is we take the function itself and set it equal to that value. Alright, now we want to be able to do the same things on graphs and charts. So if I ask if this is g, let's say this is g of x, not f of x this time. If I say what is f, or I'm sorry, I just said g. What is g of 2? So what we would do here is we'd look, these are our input values or our dependent or independent variables. So we're going to be looking at 2, run it up here to find out what the answer is, the dependent variable. So g of 2 here equals 1 because that's the value, that's the height of the curve when you put input 2. So we can do if g of 0 here, that means you start at 0, you move up to the curve, that's the answer is 4. Alright, what's g of 1? G of 1 is 2. All right. Now, if we want to go the reverse of that, we would put in a value, the reverse of that, and ask what the value is. You could write g of x equals 4. That means x has to be 0 because we knew that from up above. If we said it equals 4, then we're looking at the y value and then looking down or up to the x value. Okay, if we wanted to know when is g of x equal to 1/4. So these look like quarters here. They are quarters. So 1/4 is right here. We would go across at 1/4 until we reach the curve, and that's going to be at 4. So x is going to be 4 here when g of x is equal to 1/4. X is 4. Okay. The third type of evaluation that we're going to be doing is using a table. So in this one, we have a table of values with f of x. We can evaluate any f value from 1 to 7. So if I say f of 4, you would look here at 4 and find the value to be 38. If I want to find the f of x value, I would have to know it's one of these chart values. So let's say I want to know when f of x equals 18. We'd look through the list. Here's 18, so that's going to give us the 1 value. So x is 1 here. So reading the chart going one direction or the chart going the other direction, just like we would do on the graph. We read it in one direction or the reverse direction. And that's how we evaluate tables, graphs, and function notation.